is a one-dimensional thing. So a perimeter of a shape, what's the perimeter of a shape? Yeah, you add up every side. So if you had a rectangle, for example, the perimeter of a rectangle is if you wanted to walk around the whole of the rectangle, what would that distance be? The units we use are centimeters, meters, kilometers, something like that. These are examples, and it can be represented as someone walking around the field. So 2 dimensions then, what does that look like? Destin? Okay, so shapes, yeah. So shapes like rectangles, triangles, stuff like that are in 2 dimensions. They are like, they don't have any depth to them. You can't see, they're just flat. They have a length and a width or a height or something like that. The units we use for 2 dimensions, well, we'll think about that in a second, but what's the equivalent of perimeter? What's the space inside called?
Area.
It's called the area, yeah, we're dealing with area here. So what unit do we use? We don't use centimeters anymore, we use
Cubic meters.
We use centimeters squared. We use square centimeters, square meters, square kilometers. Now if we think of area, let's look at a shape here. Let's look at a rectangle again. 10, I'll use smaller because it's easier. 5 and 3. Okay, if we have a 5 meters by 3 meters. There's a couple of ways we can work out the area for this. Yeah, the quick way is times. The slow way is to split it up into meters squared. So 1, 1, 1, there's 3 meters here, and if I split this up into 5, I've split it up pretty badly, but split it up into meters squared. This one is 1 meter this way, 1 meter this way, 1 meter this way, 1 meter this way. That's a 1 meter square. 1 meter all dimensions. So you can count up those if you want. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 15. Now you've noticed there's a quicker way of getting there. What's the quicker way? 5 times 3. We just count how many sets of 5 I have. We'll have 3 sets of these 5. So the area of a shape will be 2 dimensions multiplied together, whatever that shape is. So in this case, the area of a rectangle or a square is length multiplied by width. Yeah. Areas are not always as simple as area of a rectangle. For instance, the area of a circle. Does anyone know the formula for area of a circle? Nothing. No, this is an area for a circle.
Everything.
Everything. Now.
A equals pi r squared.
Pi r squared. Very good. So pi times radius. That is the area of a circle. What about the area of a triangle? A slightly easier one. Darcy? Almost there. No? Schlag? Yeah, because a rectangle is actually 2 triangles put together, isn't it? That this area would be double the area of one of these 2 triangles. So the area of a triangle is half of a rectangle. So we write it a little bit of a strange way. An area of a triangle, we call, let's get rid of these sides. We call the bottom of the triangle the base. And we call this height here a special name. We call it the perpendicular height. What does perpendicular mean?
It means,
Oh, I have a question. How do you times something by pi?
Pi is just a number. It's just 3.14159. So you have to round it usually, pi. It's just 3 and a bit. How do you multiply by 3 and a bit? Well, you just use a calculator.
it just goes all along the
Yeah, okay, the final decimal place you won't know. But you'll know it's around about 3 and a bit times whatever.
Yeah, it's like 3. 3.1.
Yeah.
No, that's parallel.
Perpendicular height. It's absolutely like these walls are perpendicular to the ground. They're built at a 90-degree angle. Okay, you're distracted by pi. These walls are at a 90-degree angle to the ground. They are perpendicular. They're not at a slant. So we don't want this slant height when we do the area. We want the area of a triangle is 1/2 the base times the perpendicular height. You need that in your notebook, so can you take it down as a formula? Notice the way it's not the slant height. We don't use this height. We use this height, the perpendicular, the straight up height. Because we're really just getting the area of the rectangle and halving it. Yeah. Base times perpendicular height. Perpendicular height. This also says perpendicular height. It's not really written very well. Oh, triangle. Yeah, my writing's terrible. I'll try and do better. Triangle. So if we have a triangle like this, this would be the height we use. The straight up height of the triangle, how tall the triangle is.
Wait, can you write the area of a circle?
If you like the area of a circle, yeah.
There.
It's up there too, yeah. Is pi times radius squared. So the two dimensions here we use are radius and radius. We'll do this later on in the unit, but if you think about it, that's a circle. A radius would be this distance from here to here. Are we happy with that? So if I make another radius here, and then made a little square out of it. This is radius times radius. This has a radius square, yeah? How many of those fit in the circle?
4.
Well, 4 is definitely too many, isn't it? It's 3 and a bit times, yeah. 3 and a bit times. So there's 4 of them, but there's all this space on the outside that we have to take into account. So that's where the r squared come from, and then it's 3 and a bit times. Pi is 3 and a bit.
Why do you call it pi?
It's easier to say the name pi than it is to say all those digits.
Wait, which one am I going to say? Pi?
Which one is pi? Starts here, 3.14159, 265, etc. All the way. Okay, let me continue. We'll come back to pi another day and how it's formed. But now I just want to get on to some compound shapes. What? I'll get to it. We haven't done it yet. So a compound shape is something like this. Can anyone think what I mean when I say compound shape? What's the definition of a compound? Or sometimes composite is the word. Kira? It's an irregular shape that's made up of other shapes, yeah. So the two shapes we could have here, if I knew the dimensions here, let's say this is 5, this is 8, this is 10, this is 4. I think I have enough information to get the area of this. There's no, I wouldn't times them all together. That would suggest there are 4 dimensions. If I times 4 things together, that's 4 dimensions. We're still in 2 dimensions, so we only times 2 things together. Well, that's it. It doesn't even exist. That's why it's not the best answer in the world. This is a 2D shape. This is still 2D. I haven't done 3D yet. What would I do? What would I do? I want the area. Destin? Cut it.
Split it.
Split it.
Or you could figure out the area of the
Oh, you. This one might be better, yeah.
Wait, why don't we just do 10 times 4, 10 times 5, times 8 times 4?
because he just said that would be timesing 4 things together, which is 4 dimensions.
If I times everything together, that's 4 dimensions multiplied.
Or you could
Notice the way to get an area, I can only multiply a length times a width, or 2 dimensions together, because it's a 2-dimensional shape. If I start,
like figure out the area of like this of the place that's missing.
yeah, so the area, Fandy, you with me? Yes.
Isn't that 5 good 4?
Isabella, leave it. So I need to split it up into areas I can find. Sierra, areas I can find are 5 times 10 is this area of this rectangle. Now what's the area of this?
4 times 3.
4 from this one, but what's this length?
3.
3. How do I know it's 3?
8 minus 5.
I know that entire length is 8 and this, yes. 4 times 3. So my total area
Is 62.
is 50 and 12, which is 62.
Square centimeters.
Because I need to know this length. I can't use 8 because that's the entire length. I'm just looking at this rectangle. If I don't know what this...
Do 8 minus 4.
Well, I know that this length is already 4. I want this length. This length.
And it wouldn't be 4 because at the top of the rectangle,
five.
that's 5. So it's 8 minus 5. What's
Okay, so to find an area of a compound... To find the area of a compound shape, you have to split it up into 2 shapes. 3D. So a 3D shape, if you ever want to draw a 3D rectangle, you can do that in your book now. Draw a rectangle. Draw another rectangle that overlaps. And then connect. Top left, top right, bottom left, bottom right. And that makes it 3D. That's a cube.
You literally just told you.
Yeah.
I made it.
Okay. You can do it if you like. If you don't like the lines in the middle, you can just draw 3 at the same angle little lines and the same length little lines, and then join those edges if you don't like the.
Who needs 20 cool? Do you have an eraser?
Yeah.
No, you make it.
That's how I usually
Technically, you can also view it as another way with the 3D shape.
Yeah.
You
Yeah.
can make it look like it's facing one way.
Yeah. You can trick your eyes into having 2 different ways here.
Have you ever seen things that are 3D but use like a compound shape that when it moves, when you move, it looks like it's following you?
Yeah, there's lots of tricks you can do with this kind of stuff. 2Ds. So technically, of course, this is not a 3-dimensional shape. We need a 3rd dimension to have that shape. Kira?
Technically, the board is.
So this is still 2-dimensional because we're drawing it on a whiteboard, but 3-dimensional is everything in this space. So a box, if we see a box, I have one over there, that's 3-dimensional. What's the unit then?
What would be 2-dimensional in real life?
Piece of paper is probably about as close as you can get. Cube, yes. A little 3.
There's 3 dimensions.
Because it's 3 things multiplied. Meters times a meter is a meter cubed. So we're multiplying 3 dimensions now. So the volume is the space inside. That is what the volume. If you fill this up with water, that would be the volume of it. Well, yeah, how does an architect draw a house? You imagine, you use. Well, you could just do the formula. So the volume of a cuboid is length times width times height. Shia, can you just wait outside, please? Wait outside, thanks. Okay, so that's the volume of one of these things. You need a 3rd dimension to multiply by length times width times height. Now that's definitely the easiest of these 3-dimensional formulas because most 3-dimensional formulas have to involve circles or angles, such as if you think of a pyramid or something like that, or a cylinder like your water bottle. It's a little bit spheres. The perimeter? It depends what you mean by perimeter.
Like you got the perimeter for the second.
Yeah, so this is it. What the perimeter is, if you walk along all these 1-dimensional lines, you wouldn't need that, I don't think. But how to get the surface area of one of these? How would I get the surface area of this? So what is a surface area? A surface area is if I went to paint the outside of this, how much surface would I have to paint? So if I went to paint this room, that would be the surface area. No, that's the volume. If I wanted to fill the room with paint, it's different if I just want to paint the outside. So volume would be fill the room with paint. Surface area is I just want to paint the walls. So how many walls would I need to paint, or of this shape? How many walls? Just the outside? 6. Yes, there's 6. So how many areas would I have to get? I'd have to get, well, if it's a rectangle, more than that. But if it's a square, yes, 1 and times by 6. Yes. So the surface area of a cuboid is the 6 areas added together. So I'd have to get the area of each side. Now this, I don't have any dimensions on this, so we're not going to do this. Okay, that's a general